ESD, the sudden transfer or discharge of electricity from one object to another. With lightning, each flash is an immense discharge of static electricity from a thundercloud where it has built up into the earth below. Think about the crackling and sparks that occur when you remove clothes from a dryer. How about the shock you sometimes feel when you walk across a carpet and touch a doorknob? These examples of ESD, which we can see and feel, last for a fraction of a second and contain anywhere from about 2,000 volts, the lowest level most people can feel, to over 25,000 volts. However, below 2,000 volts, there is still enough static electricity to cause static discharge and damage electronic circuits, even when we don't feel it. Still, we're generating ESD all the time, and a lot of common objects around us can be sources of static electricity too. In fact, static zaps under 20 volts are capable of damaging or destroying the sensitive electronic components we handle every day. That transfer of static electricity, whether visible or not, is called electrostatic discharge, or ESD. This video is about controlling ESD. You'll be introduced to ESD and see how it affects the world of electronics and electronics assembly. Then we'll take a look at how ESD can be controlled in a manufacturing facility, both in the work area and during the handling, storing, and transporting of ESD-sensitive devices. Let's begin by looking at how electrostatic charges are generated. Every object has the ability to take on an electrostatic charge. The charge may be positive, negative, or neutral. A positive charge means there are more protons than electrons. A negative charge means there are more electrons than protons. A charge is neutral when there are equal numbers of protons and electrons. Positive or negative charges are usually developed when two objects are separated or moved against each other because the protons and electrons don't transfer equally. When an item has a charge, this charge is called static electricity. The word static means at rest, so we can say that the charge is just sitting on the item, waiting for an opportunity to move. When two conductive objects with different levels or polarity of charge come close together or in contact with each other, the charge rapidly moves from one object to the other. This rapid movement of the electrical charge changes it from static electricity to ESD. It is important to understand how certain materials behave with these electrostatic charges. We'll separate them into three categories. The first material we'll talk about is a conductor. Conductors are typically some type of metal, like a piece of wire. The term conductor means that this material will conduct electricity. It will freely allow the movement of electrons through it. This will enable us to use grounding techniques to eliminate charges. Grounding means providing a path for the extra charges to flow into the earth, leaving the material with a neutral charge. The second material is called an insulator. Insulators prevent the flow of electricity. As with conductors, these materials can also become charged, but grounding techniques will have little to no effect of charge neutralization. The third material is called partially conductive. Materials that are partially conductive fall somewhere in between conductors and insulators. They are conductors, but not very good conductors. The human body, most electronic components, and static dissipative materials are classed as partially conductive. They will allow grounding techniques to be used, but electrical charges are drained slowly. This is actually a desired feature in many cases, since draining charges slowly minimizes the chance of damaging electronic components. People are the biggest cause of ESD. That's because our bodies easily pick up static electricity. In fact, our skin can store relatively large amounts of this electric charge. Doorknobs probably don't mind the spark, but when ESD passes through an electronic device, such as an integrated circuit, it can cause serious internal damage to that component, resulting in a scrapped component. The tiny circuit paths in these sensitive devices can be burned up or severed by an ESD voltage, so small that our sense of touch can't even detect it. Remember, we can only feel discharges above 2,000 volts, but some ESD-sensitive components can be damaged by voltages less than 20 volts. And you won't even know the damage has occurred, but the destruction will exist inside the component. Even when the device is soldered onto a printed circuit board, it's still not safe. It can be damaged by a discharge that passes through the board's conductive pattern to the ESD-sensitive component. The amount of voltage needed to damage or destroy varies from component to component. But as these devices become smaller and more complex, their sensitivity to ESD generally increases. Sometimes the damage caused by ESD doesn't mean the component will immediately fail. Instead, the assembly passes inspection, gets shipped to a customer, and then fails later on, creating a very unhappy customer.
I'm sorry to hear that you've had all those failures.
ESD is one of the most serious problems facing the electronics industry today. If it isn't controlled, the results are higher costs, lower product quality, and angry customers, especially if a product fails at a critical time.
No, I don't want you to outsource with another vendor.
Really, 100% yield? That's great.
On the other hand, controlling ESD means product quality can be improved and costs can be kept down.
Order for 1,500 more?
This usually leads to increased customer satisfaction and sales, which is a win-win situation for everyone.
Thanks a lot.